Assalamu Alaikum, my name is Shumas. You are watching my YouTube channel. In this video, we will see that how we can simulate a heat exchanger in Aspen Hysys. So, if you don't know about the heat exchanger, you have to have a sound or well enough knowledge about heat exchangers before watching this video. So, I will directly go to my problem statement, and that states that 600 kg per hour of benzene and toluene mixture containing 44% of benzene is cooled by cooling water from its boiling point temperature at 101 to 30 degrees. So we are having a mixture of benzene and toluene that is being you can say from its boiling point, its temperature is decreased to 30 degrees, and water is used and the water is used for cooling, and its temperature is increased from 15 to 25 degrees. So let's start and neglect heat losses and pressure drop in the heat exchanger that is written in the problem. So we will go to the, first of all we will add components. The components are benzene. I will click on this benzene, click on this add. Our other component was toluene, and our last component is water that is used for cooling. So for fluid package we will take Penn Robinson. I will select Penn Robinson. After this there is no chemical reactions involved, so we will directly go to the simulation environment. Here I will click on this heat transfer, and this is our heat exchanger. So I will drag it onto the main window, and I will double click to enter the requisite properties. So when you will double click it, you will see a window like this. So tube side inlet and shell side inlet. As if you know about the heat exchanger has one fluid. There is no direct contact between the two fluids through which heat is transferring. One fluid is present in tubes and the other fluid is present in the shell. So this happens. So I will name this tube side inlet as, I am going to name these streams. I will name this stream as hot inlet 1. This is outlet, so I will name is hot outlet. So this is our shell side and this is shell side, so I will name it as cold in. I will, and this I can say as cold out. So now I will go to this worksheet directly, and first of all I will go to design and parameters. So here I am in this problem we have to take simple endpoint and heat loss is equal to 0. So in the next video I will teach you how to design rigorous shell and tube, that is the actual shell and tube designing in Aspen Hysys, taking in view of all the variables and heat transfer coefficients, etc. So we were having the flow rate that was 6000. So I will write as 6000 kg per hour, and the pressure was 101. So I will write as 101. Temperature temperature was the boiling point, so we don't know about the temperature of the inlet steam. So I will now so the benzene was 44%, so I will write 0.44 benzene, and the remaining will be and toluene, so it is 0.56. So now I had the basic requisites I had filled. I was given that its temperature from its boiling point was changed to 30 degrees, so I will write as 30 over here. Temperature pressure was no pressure loss, so I will write 101 here as well. So in the problem it was written that water that was used for, so I I will again show you the question. The cooling water was entering at 15 and leaving at 25 degrees, so we will water inlet will be at 15 degrees and water outlet is at 25 degrees. So pressure is again same 101. So here I have to define the composition of this cooling water. So I will just define the composition of this water that is cold in, that is overall water. So you can see that our system is written that it is underspecified. So as we know that in the question it was written that the mixture is from its boiling temperature. So when it's mean that it must be a saturated liquid, vapor. So I will this vapor I will write this as 1. When I will click this 1, you can see that all of the it is written over here okay, and all of our variables has been solved. So if the flow rate that is required of water to cool this from 98.79 to 30 degrees, so the flow rate required for the water is this 6.8 multiplied 10 raised to power 4, you can say that 68,013 kilomole per hour flow rate for water is required. From this problem you have also find the boiling point of this type of composition, that will be 98.79. So I hope you like the video. In this video I had explained that how we can simulate a heat exchanger with the help of problem in Aspen Hysys. I hope you will like the video. In this next video I will show you the detailed shell and tube rigorous analysis. This rigorous shell and tube analysis, we will see that how heat transfer coefficients take into account while designing the shell and tube heat exchanger. So I hope you will like this video. Please subscribe my channel, share my channel if you like the video. Aslam Alaikum.